In the late 19th and early 20th century, the elevator was changing cities around the world.
Thanks to this innovation, skyscrapers became practical for the first time. And soon, the race to see who could build the biggest building was underway.
In 1912, the Equitable Life Assurance Society of the United States asked their architects to design a New York City headquarters that would be the envy of all the other towers in Manhattan.
There was just one problem. Elevator technology was good, but it wasn't quite as good as the building owners' imaginations. So they told their architects, if you can't go up, go out.
At over 1 million square feet, the Equitable Building did become the largest office building in the world when it opened in 1915. But it did not open to great acclaim.
Here's what Real Estate Magazine said at the time.
It's a monstrous parasite on the veins and arteries of New York City.
And a New York City report the following year called it
A notable illustration of the evil effect of a building that covers too much land.
To understand what was just so evil about it, we decided to go and see this monstrosity for ourselves.
We are in the shadows of the Equitable Building right now.
Across the street on Broadway, it's covered in shadows. It's just one big shadow, which actually looks kind of nice because it's pretty hot out today.
So you can imagine in the early 1900s when electricity wasn't such a big thing that it would have been kind of problematic to have your office completely blocked out with the Equitable Building's shadows.
And the shadows casting over this little public square that is right beside the Equitable Building because the Equitable Building's so tall.
It's not just tall, eh? It's like girthy. It's like very like wide, and I really do think it takes up this entire city block.
It goes all the way to the other block, and it's like consistently wide and massive, whereas a lot of the other buildings around here, they're kind of narrow.
The hullabaloo that was kicked up around this building shadow is actually the reason why New York City had its first zoning laws passed.
Is that because others were upset that they got blocked from the sun?
Exactly. And so actually what happened is because of those early zoning laws, now skyscrapers have to do something called a setback. So it's actually really easy to see in this building right here next to the Equitable Building, which I'm going to guess was actually probably constructed afterwards. See how it kind of like tiers up? It's kind of like a layer cake where each layer of the cake gets a little bit smaller, up and up and up.
Right. And I can see a little more sunlight casting over there, so maybe that was the point.
As the history of the Equitable Building shows, every urban development project has trade-offs, constraints, and unintended consequences.
But the goal for architects and developers should be to anticipate as many of the effects a given choice will have as possible.
But it's not easy. Even today, designing a building is a very time-consuming, expensive, and fragmented process. If one person makes a change, it takes a great deal of money and effort to know how the repercussions will ripple across the project.
And over time, these costs lead not just to more expensive development projects, but to less affordable cities, too.
Fortunately, there's a whole new field that uses machine learning to help architects, real estate developers, and urban planners better understand how their designs might impact communities.
And choose designs that work better for everybody.
It could even give communities greater voice in shaping their neighborhoods.
Welcome to City of the Future, a podcast from Sidewalk Labs.
Each episode, we explore ideas and innovations that could transform our cities.
We're your hosts. I'm Eric Jaffe.
And I'm Vanessa Quirk.
And in this episode, we're talking about an innovation that could help us make better decisions about how to build communities that work for everybody.
Generative design.
So I was first introduced to generative design back in architecture school.
That's our colleague, Violet Whitney, an architect and programmer. She's been thinking about the ways technology can improve urban planning for quite some time now.
And for the last few years, she's been really excited by this emerging field of study called generative design.
So can you explain what generative design is exactly?
Sure. It's the process of automatically producing many designs.
Mm-hmm.
So basically thousands of options based on goals and constraints you feed into a computer.
Okay.
So you can apply generative design to anything, really, but you could use it to automatically produce thousands of designs for a chair, for example,
Mm-hmm.
and then see which chair is optimal based on your goals for the chair.
So you put into the computer, like, world's best chair, please.
Yeah, right. Best according to whatever you told the computer was best for you.
Uh-huh. Okay.
So at Sidewalk Labs, we've been wondering, how could you apply generative design to something as complex as the urban planning process?
Violet is part of a team of designers and engineers that have built a product that generates thousands of design options for any given development project. The idea is that this product could help urban development teams find the best designs for a building, a neighborhood, even a whole district. They call it Delve.
Delve uses machine learning to produce radically better urban designs in a way that just wasn't possible before.
Over the summer, we asked Violet and her colleague Brian Ho to give us a sneak peek of a beta version of the product before it launched this fall.
All right, so can you guys describe what we're looking at here?
This is what we call Anywheresville, actually.
You have a 3D building environment, but we're kind of looking at it from an above map view where we see the entire district.
Okay, so I see streets, I see parks, I see buildings.
How did Delve produce the neighborhood design we're looking at?
So one of the first things that we always do is to onboard all of the constraints and the local rules and spatial guidelines that might exist.
One of those is often zoning. We can encode maximum heights. We can do things like setbacks. And so anything that you can get from municipal open data sets, if there is data that is relevant to a project and it exists in a GIS form, we can go and bring it into the project.
Okay, so now that we know that our plans aren't going to violate, zoning codes, can we get to the fun part, the generating of the best designs? How does it work?
We'll start with the stakeholder, whoever's developing a site, and they'll have goals and objectives, like this much residential space, this much open space, make sure that everything's within a 5-minute walk distance. And then from there, we'll put those goals in, and that's when Delve starts generating the best options for them.
Some things have trade-offs. You can't optimize everything all at once. What the tool is essentially doing is negotiating that complexity.
And to that point, there's this little scorecard that's popped up here in the bottom of the screen, and you can see the population, you can see how many jobs, you can see how much commercial space there is. And I imagine that changes based on the configurations you're putting on top of these parcels.
Yeah, so I've selected an option here. This is iteration 163.
You can see it has a daylight score of 57%, whereas this one, iteration 204, optimizes for density, and it has a daylight score of 32%.
Yeah, oh wow, yeah, you can see right away, it looks so much denser.
It's possible that audio is the worst medium for this conversation because when you look at it, it's just so obvious and clear and striking. The visual differences and the types of scores you're going to get and the types of community you're going to live in.
Audio challenge accepted, Eric. So in this iteration, let's call it Sunshine Place. None of the buildings are too tall. They're kind of like far apart from each other, separated by a lot of green space. So I imagine kids running around. Maybe there's benches so you can sit down and soak in that sunshine. The birds are really, really happy here. And because the buildings aren't too tall, Sunshine Place gets a very high score for daylight access. It doesn't cast shadows onto other buildings or other public spaces.
I like the bird sound effects.
We should actually put these sounds in the Delve product.
Yeah.
So that if you click an iteration with open space, you hear birds.
I want to optimize for bird chirps.
Oh my God, I love that.
All right, I hate to burst your bubble here, but this density score, the amount of residents in this place, it's terrible, right? No developer would be able to make their project economics work with that small of a population.
Okay, this is a valid point. And also, I want it to be affordable for a lot of different types of households. So, okay, let's look at another option. The other one, let's call this one Dense City. Get it? Dense City?
I award you no points, and may God have mercy on your soul.
Oh, Eric. Well, then you describe it then.
All right, there's lots happening here. There's tons of super tall buildings. They're crammed close together. It's almost like Midtown Manhattan a little bit. There's only one park here, and it's a central park. It's located in the middle of all these tall buildings. But I'm guessing that this park has a shadow problem being surrounded by all those towers.
Right, I'm imagining trying to set up a picnic blanket in this park and having to move every few minutes because the shadows keep shifting across the park with you.
Yeah, and it looks like the daylight axis here is 32% on average. We've dropped 25 percentage points through the distribution of massing alone.
Right. But a lot more people can live here in dense city compared to Sunshine Place, and they don't have to walk far to get to stores or get to transit for their jobs or get to the park.
And to your earlier point, for the developer, you're probably more likely to get a return on your investment in this option.
And that's a very big part of a trade-off.
But clearly, if we just needed to generate two very different scenarios like these ones and choose between them, you wouldn't need a product like Delve, right? I mean, any architect could create two scenarios. I think what's different here, Violet, is that Delve uses machine learning to generate thousands of these kinds of scenarios just in minutes, right?
Yeah. Initially, when we started on this project, we were thinking a lot about trade-offs. But now we're thinking a lot more about how Delve can produce options for a site that we just didn't even know were possible before. There's 1,000 options out there that might be much better to live in. And Delve doesn't just generate all these new options, it actually helps you find the best design for all the different stakeholders.
Let's pause on that for a second, because we know from history and still today, development is very complicated and it's often fraught. Right? It's hard to create a building, a neighborhood, a district that takes into account the needs and priorities of all the different stakeholders involved, whether that's architects, developers, or community members themselves.
Right. And then the question becomes, can we use technology to do that, to help us make better, more human designs?
That's a big question. And it's one that architects have been asking for quite some time.
Well, I think there's an interesting question when you're looking at generative design about where creativity comes from. Does creativity come from a human, or does creativity come from how humans work with technology in different kinds of ways? Could a computer suggest options to you that never might have come to mind or made you think very differently about a problem?
That's Molly Wright Steenson, a writer and historian at Carnegie Mellon, whose work centers around the intersection of architecture and computing.
And what's exciting about Molly's work is that technology today is finally catching up to the visions of the architects of the 60s and 70s, who were back then just dreaming big.
The big ideas were there years ago, but the possibilities for actually putting those big ideas into place was not.
One architect with such big ideas was Cedric Price, who we've talked about on the show before.
In the 70s, Cedric Price worked with software developers on a project called Generative, which he imagined as a building made up of cubes that, thanks to different computer programs, could be moved around by the people visiting it.
The most important program they created was a boredom program. And basically, in the event of generators, parts not being moved around, it would start coming up with its own layouts for itself.
I love that. He was so ahead of his time. It was great.
He's amazing.
Because when we talk about generative design today, we talk about simulations, not reconfigurations of a building in real time. The fact that Price was trying to do that, it's just so neat.
And unfortunately, like most of his work, it wasn't built. The project got canceled. But what I like so much about Cedric Price's work is that he wanted to make you think differently about how you use it and what it meant to be designing it and what it meant to be the architect even coming up with these ideas.
Price wasn't the only architect of this era who wondered if computers could show architects another way.
Christopher Alexander is one of the very first architects to use a computer.
Christopher Alexander, who you may know as the author of A Pattern Language, preached that the best spaces are built by the people who live in them, not professional architects or designers.
He felt that designers had biases that made them do designy things, right? And that kind of the self-importance of a designer or architect might make them make design decisions just for the flourish and not for what would actually make for good design or fair design or just design.
Here's Christopher Alexander in 1996, addressing a crowd of computer scientists.
Now, in our time, the production of the environment has largely gone out of the hands of people at large in society, and it's a serious problem. That's a debatable matter. Some people would say, what are you talking about? It's all absolutely fine. I suppose the architect of this particular room would say that. But actually, it isn't fine. It's a hell of a problem. Already, most of the habitable environment is something that has been built in these last 50 years. So the fact that it is not nurturing is a very, very drastic matter for all of us.
Alexander had the radical idea that we should just ask ordinary people how they feel about a design.
Questions like, are you happy here? Do you feel good, bad, wonderful, comfortable? And then he'd use that feedback as the basis of the design process.
Architects and developers weren't the biggest fans of Alexander's idea of sharing space at the drafting table.
But computer scientists, they loved Alexander. They used his work as inspiration for user-generated spaces on the internet like Wikipedia. And in 1996, a few famous computer scientists invited him to keynote that conference you heard earlier. Here's another clip.
Compared with the pattern language of mine that you've seen in the book, my colleagues and I have written things that are much more like what you call code. They're generative processes which are more like sets of instructions that produce things. Because of the complexity of the situation and because of the way software is going, software that was designed to do that could very rapidly take the world by storm.
Wow. I mean, that sounds a lot like what Delve is trying to use software to do.
And you can see why Alexander felt that computers could, one day completely change the way that buildings and neighborhoods are designed using inputs like what people actually want out of their neighborhoods.
Yes, but one thing missing from Alexander is the visualization element, right? It's easy to ask someone how they feel about an existing project. It's really hard to ask people how they feel about a project that doesn't exist yet.
Well, according to Molly, apparently Alexander did start thinking about this question of visualization in the 60s, but he gave it up to think about other areas of research. But in the 70s, a different group of computer-oriented architects picked up where he left off.
They were all at MIT, and they called themselves the Architecture Machine Group.
They went to Aspen, Colorado with a Jeep and put a lot of movie cameras on it and drove down the streets and gathered footage.
It's almost like Aspen got their own Google Maps 3 decades before the rest of us.
The Architecture Machine Group called it the Aspen Movie Map.
You could sit in this Eames lounge chair that had joysticks in it, and you'd zoom down the streets of Aspen, Colorado. And on one screen to your left, you would have a satellite map, and on the screen to the right, you'd have a touchscreen map. It was an idea for, maybe you could get stories or people to come out of the different buildings, and you could interact with them along the way.
Okay, so it's not a design tool per se. It's more like a way that anyone can virtually experience a design.
Right, but imagine if you could allow people to have that visual experience of how a place would look and feel before shovels go into the ground. What could that mean for the planning process?
As planners, we're thinking and looking at 2D site plans all the time, so we kind of have a picture in our head of what a building in a particular location would look like. The residents, they don't think about it too much.
That's Evan Lowry. He's a geographer and planner for the city of Charlotte, North Carolina.
One of the things Evan is responsible for is keeping track of his city's growth. And it's been growing fast.
It's been around 15,000 people a year for, the last 10 years.
To help model out what Charlotte could look like in 20 years' time, the city is using a visualization software.
So could you explain why the ability to visually experience these models is so important? Is it a game changer for you?
Yeah, well, I think it's more of a game changer for the residents. If they can pull up a website and turn a layer off and on, see how it relates to their own house, their own neighborhood, that will definitely be a game changer in community engagement.
Charlotte hasn't rolled out their visualization tool to the community just yet. But when they do, it will allow community members to give their feedback online.
The way that this happened before COVID, the residents would be expected to either come to a meeting at the government center or maybe somewhere in the community. Now the push is towards, more online virtual engagement, which I think it has the opportunity to reach more people.
Evan thinks this type of participation wouldn't just be more accessible. It would be more meaningful, too.
You would be able to make your own assumptions and your own comments based on what it would look like if you were standing there and you could see it. In the future, I would like to see it become a more interactive process in the design. The residents would be able to sketch out their own vision of what a development would look like. I think that would be very powerful.
I can really understand now why generative design has the potential to really transform development, because it's exactly what Christopher Alexander was dreaming about, a technology that lets you incorporate the needs and feelings of a lot of different kinds of people and not just architects.
And like the Aspen movie map, we can potentially experience the project virtually, so we know what it would feel like to live in this place.
And not only that, but like Price wanted, generative design allows for all these new possibilities too.
But let's get to practicalities here. Of course, community members should have the best tools to provide the most meaningful feedback into a development project like they're trying to do in Charlotte. But how can generative design help with the very messy task that falls to cities and development teams of weighing all these competing priorities?
At the end of the day, how do you make a decision on which plan to move forward with?
You're asking the million variant question, how do we go from many to one?
It's a question Brian and Violet hope that Delve can help cities and development teams answer.
The idea is not that you click a button, you get a design, you print it, and you walk away. It's really the opposite. We really want to go in and augment and give superpowers to designers, planners, developers who are out there working with communities, trying to build better places.
And we're thinking about future iterations of Delve where community comments can actually become constraints. So the designs would be held accountable to the community's needs. And that would ensure that when we put out designs, a community can say, yeah, this actually meets this check mark. It has this much daylight, or it's this walkable.
Or it has this many birds chirping.
Yeah, exactly. And if we can achieve that, then we can measure how successful a project is according to how well it meets people's needs or improves their quality of life.
And if you do that before a shovel even hits the ground, the community can really understand what this project will mean for them, right? And how it will work for them before it becomes a reality.
And that will really change the way we plan not just buildings and neighborhoods, but cities too.
Brian and Violet are hoping that Delve makes it possible to bring more voices into the development process.
And if it does, it will show that, generative design can help us make better, more human designs, buildings, and neighborhoods.
Bringing our cities out of the shadows and, just maybe, into a brighter future. Thank you for listening to City of the Future, a podcast from Sidewalk Labs. Your hosts are Vanessa Quirk and me, Eric Jaffe. We are produced by Benjamin Walker and Andrew Calloway.
Mixed by Zach McNeese. Special thanks to Violet Whitney, Brian Ho, Molly Wright Steenson, Evan Lowry, and Andrew Calloway for his special appearance as the mid-Atlantic old-timey guy. Thanks, Andrew.
Our art is by the great Tim Cow. Our music is composed by Adam James Levine Arity. If you want to hear more of Adam's work, you can check out his band, Lost Amsterdam, at amsterdamlost.com.
To learn more about Sidewalk Labs, visit our website at sidewalklabs.com, where you can subscribe to our newsletter at the bottom of the page. And you can also follow us on Instagram at City of the Future Pod.
See you in the future.